Okay, Spring Data Access or Spring Persistence presentation. So we will talk about the concept of DAO, Data Access Object, and we'll talk about repository annotation, and then we are going to look into three different data access technologies, JDBC, and Hibernate, and JPA. So here on the JDBC, we are going to look into some convenience classes that are provided by Spring Framework. And then we are going to spend some time on how we can use Hibernate or JPA under Spring Framework. So DAO support. So why DAO? DAO stands for Data Access Object, and Data Access Object pattern is used to provide the consistency and portability of your application regardless of what data access or persistent technology that you use underneath. The idea is that I like to be shielded, meaning my code is I like to have my code to be shielded from the selection of a particular persistent technology, whether that technology is Hibernate, JPA, JD, or JDBC, so that the switching to a different persistent technology should be a matter of changing a few lines in the configuration file rather than forcing me to change my code. Now, one of the things that are challenging if you're not using, for example, DAO of Spring Framework, basically you have to actually deal with persistent-specific exception classes yourself, right? And that's causing your application to be persistent technology specific code, dependent code. So instead, you want to be also shielded from those technology specific exceptions. Okay, so that's something that the Spring Framework will support. And we'll talk about that. Yeah, so this is basically consistency exception hierarchy that I just talked about. So Spring provides a convenient translation from persistence technology specific exceptions like SQL exception from JDBC layer to its own exception class hierarchy with data access exception as a root exception. So Spring has its own exception hierarchy that are in fact abstracted, meaning these exception classes in Spring Framework will be able to be used on any specific persistent technology, whether again you're using JDBC or Hibernate or JPA or whatever persistent technology of your choice. Now, this data access exception object also captures original exception. So if you want to poke around the original exception, you can certainly do that. Yeah, so this is a bit hard to read. So this is the Spring Framework persistent technology exception hierarchy. So again, on the top, you have a data access exception class, meaning these classes could be used over any persistent technology. So that's the portability and consistency Spring brings into your persistency, your application that using persistency. Okay, moving forward, repository annotation. So you can use repository annotation for your DAO class or repository class. You can think of just a DAO class. And basically, by using this annotation, you are asking Spring Framework to handle the exceptions with the that data access exception hierarchy. Okay, so basically, you're asking the Spring Framework to generate Spring Framework abstracted exception whenever there is a problem, rather than persistency technology specific exceptions. By the way, repository is a stereotype of component. What it means is that this is like a sub annotation of component annotation. If you remember, component annotation, basically by specifying your class as component annotation, you're basically enabling auto scanning by the Spring Framework so that the object of this component type class will be automatically created. Because add repository is the stereotype of component, again, if you have add repository on any class, then Spring Framework will create an object instance of this one without you specifying in in the Spring Beans.xml file. Okay, so access to persistence resource. So any DAO repository implementation will need to access to the persistence resource. And now depending on the persistent technology used, you will actually use a different resource. In the case of JDBC, you are going to use JDBC data source object. For Hibernate, you are going to use session factory object. For JPA, you are going to use entity manager object. Now, the easiest way to get these objects is by having dependency injected, by using resource dependency injection. So you could use AutoWire for database, the JDBC data source or Hibernate session factory. For JPA, we could use persistence context annotation. So let's see examples of this. So this is an example where we are the dependency injecting the JDBC template object. Well, actually, yeah, so let me repeat. So this is your repository implementation class, and we're going to talk about JDBC template later on. Now, when you create a JDBC template object, you have to specify JDBC data source object, right? So here you are basically auto-wiring data source object by using @autowired annotation on init method here. Okay, so basically you're saying that I want data source object is created by Spring Framework, and then I want that object to be dependency injected for me so that I can use it right away. Okay. Okay, so that is the case that we are injecting. Well, we're asking Spring Framework to inject JDBC data source object. This is the case that we are asking Spring Framework container to inject Hibernate session factory object. So here again using @AutoWire at the method. Okay, and here session factory object will be created by Spring Framework container and will be injected into this code. For JPA, there is a special the annotation called persistence context. Okay, so here you are asking the Spring Framework to create entity manager object and inject it into your code. Okay, so let's talk about how we can use JDBC in the context of Spring application, and then we're going to move on to Hibernate and JPA. Now, Spring JDBC is actually handling a lot of chores for you. Okay, so these are the things that if you're not using Spring JDBC, I mean, all these things is something that you have to handle yourself. However, if you're using Spring Value Add JDBC classes, the chores like opening a connection and preparing and execute the statement, set the loop to iterate through the result, and things like that will be all, and also important thing is process and exception. These are all handled by the Spring Framework. The things you have to do is basically define connection parameters and then create SQL statement and then specify the parameters that could be fed into SQL statement and then do the work for each iteration from the result set. So you are mainly focused on the core functionality of JDBC rather than the boilerplate code, because the boilerplate code will be handled by Spring Framework. Okay, so the options that you can use for JDBC access, there are 3 different flavors. JDBC template, the most basic one, and then you can use named parameter JDBC template class or a simple JDBC template class. Okay, and you can also use simple JDBC insert and simple JDBC call for the then you can also use mapping SQL query and SQL update and the stored procedures. So these are all, let's say, provided by Spring Framework. So let's take a look at each of these classes in a bit more detail in the following slide. Okay, so first, JDBC template class. So this is the most basic JDBC template, JDBC class from Spring Framework. So it handles the creation and release of resources. Okay, so it also helps you avoid common errors such as forgetting to close the connection because it handles it for you. And it performs a basic task of core JDBC workflow statement, for example, creation, execution, and things like that. And then it executes SQL queries and catch the exceptions. So let's see the code. So here we are we are basically we have a JDBC template object, and then we perform query operation, providing SQL statement. Okay, so this is a very simple query using getting number of rows. Okay, this one again we are using JDBC template class, and then call query for int, and here we have SQL statement, and we have some parameter, and here is basically a simple query using a bind variable, meaning we provide a parameter. Okay, so the question mark is fed by a parameter. So you have only one single question mark, right? So you have a single parameter. This is for querying for string. So here we are again calling query for object method of a JDBC template. Again, you provide SQL statement and arguments to bind to the query. So in this case, we have only one argument. And the string class, this is a required type. This is a type the result object is expected to match. So here we are basically expecting string object. Okay, so another example of JDBC query is that we can specify row mapper object. Okay, so this is the this is the required type, meaning the type that result object is expected to match, right? In this case, we are basically using row mapper class, and this row mapper is the this actor type. This is my own class called the actor, and for each row that is returned from the result set, we are creating actor object. Okay, and we set the actor object the first name and last name, okay, from the result set. So this is a convenient convenient class that we can use to map a row that is returned in the result set into an object, in this case actor. Moving forward, and then we can also call update. Okay, and yeah, so these are different kinds of the update. So using here question, and we are saying providing two parameters. Okay, same thing here, same thing. So here we have a single parameter. This is execute. Okay, so execute method. And this is a case that you can use the stored procedure. Okay. All right, moving forward. So as you can see, you can use a JDBC template to perform pretty much all SQL operations without writing boilerplate code. Moving forward, named parameter JDBC template class. So this is a bit more convenient than JDBC template class. So named parameter JDBC template adds support for programming JDBC statement using named parameters as opposed to using the question mark arguments. So when you're using question mark arguments in these examples, okay, if you have a multiple of those, you have to be responsible for specifying the right values in the right order. Okay, so if you in fact have, let's say you have a two question mark, right? And this one goes to the first and this one goes to the next, meaning you have to be responsible for making sure these values are in the right order. So if you mix these two up, then it might actually result in the wrong the query operation. Okay. Now, if you're using named parameter JDBC template class, then instead of using those position-based arguments, you can specify the names. Okay, so it's a bit more convenient. Okay, so let's see example of this. Oh, okay, so you can also actually use SQL parameter source interface there are in fact two different implementation of the SQL parameter source interface. You can use a map SQL parameter source or a bean property SQL parameter source. Okay, so let me explain these things using example. All right, so here we go. So here, let's say I have SQL statement. So instead of specifying question mark, I'm actually using a name of the parameter. In this case, colon first name. Okay. Now you can now create what is called the SQL parameter source object, which is in this case you are using concrete class called the map SQL parameter source, and then you specify the name of the parameter and the value. Okay. And then you can pass the SQL statement that you have here, and then this SQL parameter source object. Now here, since we have only one single parameter, it might not be a big deal. But if you have in fact like 10 of those, right? Using this naming is actually more convenient because you don't have to actually be concerned about the order of those 10 parameters. You're going to use the names. Okay, so more flexible than the question mark based parameter passing. Okay, moving forward, simple JDBC template and simple JDBC DAO support classes. Again, these are, let's say, utility classes that are provided by Spring Framework, and the more convenience for the convenience purpose. So simple JDBC template class wraps the classic JDBC template and leverages Java 5 language features such as var args and auto boxing. So var args is that you can specify variable number of arguments. Okay, so let's see the example. So this is the case that we are not using simple JDBC template. Okay, so this is the classic JDBC template class. So when you're calling JDBC and then you call query for object and you specify SQL statement, right? SQL statement. And then you are going to specify set of object. Okay. So here again, you have to actually specify a set of, set of objects, set of objects in the form of array object, array of object, array of object. Okay. So the if you want to pass, let's say the multiple number of arguments, then you have to create this array object. Okay. Instead, in Java SC5, Java SC5 supports variable number of arguments called the var args. You can actually call simple JDBC template. Now you're using simple JDBC template class, and then you can actually specify variable number of arguments. Okay, so you could have multiple arguments without actually causing any problem because now JDBC template query for object is actually using var args syntax. Okay, so instead of creating array of object for passing multiple or different number of arguments, now you can actually specify those arguments right here. Okay, all right. Simple JDBC DAO support is extension of JDBC DAO support. It will expose simple JDBC template. So here, basically, if you're extending simple JDBC DAO support class, then you can get the simple JDBC template object by just calling get simple JDBC template method. Okay, so it's not hugely, the more convenient than previous examples, but a little bit convenient, meaning you can just get the simple JDBC template object by just calling get simple JDBC template method. That's all. Okay, so first demo is we're gonna try simple JDBC DAO support and simple JDBC DAO support error handling, and here is MySQL. So I'm gonna actually use the documentation a bit, and then I'm gonna just run the application. So if you have an access to the hands-on lab, feel free to download it and try things with me. So here, exercise 1, we are trying JDBC with HSDB. And here we are going to see how error handling is captured in the form of data access exception class object. And here, exercise 3, instead of using HSDB QL, we are using MySQL. Okay. So here, basically explaining those classes that we learned through the presentation. So when you run the application, it's going to display this value. So let's run that. Simple JDBC DAO support. We are going to run as Java application. And we select the main method. And result is basically it's just displaying the first student. Student number 1, name is sanction, birthday, grade, and things like that. So let's see the code. Now I want you to actually, see the code and also structure of the configuration file. So this is a domain class. I'm sorry, this is the main class, and this is the domain class student. Student class is very simple Java bean. Okay. So student has student number, name, birthday, and grade. Okay, and then we have a get and set a method. Nothing really uh, unique. And then we have a DAO class. So we have student DAO class, which is an interface. Okay, this is student interface, student DAO interface, providing some persistent method: insert, update, delete, find by student number, insert batch, meaning we are going to insert a list of student object, and then we do find all, get name, count all, and things like that. Now we have a JDBC student DAO class, so let's actually see the code here. So here we have implemented simple a student DAO interface. Now we are extending simple JDBC DAO support class. Okay, so here we create this SQL statement. So these are the names, named parameters: student number, name, birthday, and grade, right? And then we create, in this case, we are using bean property SQL parameter source object, and this class is used to use a bean object. We have a student object, right? And we are using student object's property values to set the SQL parameters, okay? So whatever values, property values of student will be feeding these named parameters, okay? And then we call update method of SQL, and then this parameter source object. Same thing for insert batch and find student number and update. It does work pretty much the same. Okay. All right. That is JDBC student DAO class. Now, if you take a look at the main Java, so we read the beans.xml file, and we'll take a look at that in a few minutes. And then we get the student DAO object, and then we create a student object, and then we perform insert through the DAO object. And then we call find by student number, providing O1, which we have used when you create a new student object. And then we basically display the values. Okay, very simple. Now, in terms of structure of the configuration file, so we have a beans.xml file. Okay, that was accessed. Now, it doesn't do anything that much except that it's importing application context JDBC XML file. Okay, so on the Spring, so here, this is the JDBC XML file. So here, if you take a look at the JDBC XML file, we are importing data source XML file, and here we also define student DAO class, which is this class, and then it's using data source object. Okay, and this data source object is defined in this configuration file, application context data source.xml file. So if you take a look at the application context data source XML file, here we define the context property placeholder. So we're actually reading JDBC properties file. Okay. And then from the properties file, we are setting these values like a driver name, URL, username, and password. Okay. And then we're also actually using the the initialization of the database. Okay, so it's actually picking up the the some file for initialization of the database. Okay, so let's take a look at the this properties file. So the properties file is, yeah, this one, JDBC properties. So here we are basically defining properties of various databases. In this case, SSQL database. And yeah, so that's the one that we are using right now. So the driver name and URL and SA. Okay. And now it also defines the init location properties, which is in this case initdb.txt file and populateDB.txt file. So this is used, these files are used for creating a database tables. Okay. So if you take a look at the shqldb initdb.txt file, it's basically you know, the SQL statement for schema for creating a student table. Okay. So, you know, for simple application, we have in fact a multiple, let's say, files involved here, but it's actually designed to be more flexible. So, for example, if you want to change if you want to use MySQL, you know, basically you can specify in the JDBC properties file, you can specify this one instead of HSQLDB, you're going to say MySQL. Okay. So these are actually, you know, the kind of the separated out into different files to have more flexibility for changing. All right, so hopefully that gives you a sense of how things work. Any questions on this? Yeah, I feel like I kind of move a bit faster on reviewing this code. But I strongly recommend you to download the hands-on lab and try things out yourself. You know, you probably have to spend some time to looking this configuration file. Okay, so let me just repeat one more time the configuration file because I felt I kind of moved too fast. So here we have beans.xml file, which is in this case just reading JDBC XML file. So later on, if you want to use JPA, basically you are going to change this file to use application context-jpa.xml file. If you want to use Hibernate, then you are going to use application context-hibernate.xml file. That's pretty much it. So that's the reason, you know, we are actually kind of having this separation of the files. In this case, JDBC XML file is defining JDBC specific, you know, information. In this case, a DAO class, and it's using data source object that is defined in this application context data source object, the XML file. So here, you know, we are basically defining properties through this JDBC properties file. Okay, so here we are defining the data source object, and also we are specifying the initialization, the text file, which is used for creating table. Okay. All right. See, I have a question from Jason. When to use JDBC template and JDBC simple JDBC template. You know, JDBC template is the lowest level, so you know you might want to actually use a simple JDBC template because it provides a little bit higher level abstraction. I noticed a second question from Jason is that I noticed you are using connection pooling. Does that help with the Spring JDBC? Yeah, connection pooling has nothing to do with the Spring here. You know, connection pooling is is used for you know, basically the sharing your connections. Okay, so you know, you can use the driver that doesn't have a connection pooling, or you know, you could use a connection pooling based data source object. So that, you know, basically is JDBC kind of concept. Okay. Let's see. So, you know, whether you're using it with a Spring framework, it doesn't really, you know, I mean, it's not really a Spring specific thing. Okay. So connection pooling is again providing the pool of connections, as well as you save time for not creating or destroying the connections. Okay. All right. So let's move on to The next example is, yeah, so we study this project. Yeah, I explain all these things. JDBC with the error handling. So this is the case that we are capturing the error conditions. So what we are doing here is that we are going to, let me actually show the code. So let's run this case. Error handling. So if you run the code, yeah, this time, in this case, we're actually forcing an exception. So here, you see the message, violation of unique constraint. Okay. If you take a look at the code, so we create the first student, okay, and then we're creating the same student with the same ID. Okay, so this should generate an exception. So here we are capturing as data access exception object. Okay, and if you want to find out, exactly what that error message is, then you can also poke things around. So here we can, get the SQL exception object from this object. So we can get the cause of it, we can get the error code, SQL state, and things like that. Okay, but idea is that we like to capture that exception using this high level, the data access exception, the class object. Okay, and the next one is, so your exercises this time, if you want to modify it for your own exercise, you can add this table to check grade is greater than 10. Okay, so if you're adding a student whose grade is not greater than 10, that should cause an exception, and you want to capture that as data access exception object. And exercise 3 is using JDBC with the MySQL. So again, the code is, so here we're studying MySQL, and the result is pretty much the same. In this case, the only thing that you're going to change is, for example, you're going to change the JDBC properties file. So instead of using SSQL settings, you're going to use MySQL settings. Okay, and then it's going to use initdb.txt file of MySQL. Okay, so the syntax is going to be a bit different from HSQL. Okay, but that was about it. Then it's going to run. Okay, so your code doesn't have to be changed regardless of what database server you're using, whether it's a HSQL or MySQL. Okay, all right, moving forward. All right, so that is a JDBC. Now let's talk about ORM support in Spring Framework. So ORM, basically either Hibernate, JPA, or JDOR, and IBETIS, but we are mostly focused on these two, Hibernate and JPA. So benefits of using ORM is easier testing, common data access exceptions. Again, we are talking about Spring ORM, general resource management, and integrated transaction management. So we are going to actually take a look at all these things. So let's talk about Hibernate. So there are two different options for mapping domain class. You can use Hibernate, domain mapping class XML file, for example, student.hbm.xml file, or you can use JPA annotation, like using entity annotation. In this case, you don't have to have XML file like this. Okay, so trend is, this is in fact a preferred method moving forward. Okay, so this is option 1, in which you are going to use XML file. So here you are going to use Hibernate 3 local session factory bean, and then inside that bean declaration, you are going to have a property of mapping resources, and then you are going to have a list of all mapping, domain mapping XML file, student.html.xml file was teacher.html.xml file and things like that. And then you also set the Hibernate properties. And you also have to, in this case, the student.html XML file. So this is just Hibernate, the domain, the mapping file. Okay. So in this case, you have a student, table student, and ID and properties. Okay, option 2. This time, instead of using domain mapping XML file, we want to use annotation like identity in the domain class. In that case, the bean you're going to use is annotation session factory bean, and here then you're going to have annotated classes property in which you're going to list all the domain classes. So in this case, student. And then if you take a look at the student class, it is annotated with add entity. Okay, and the table name is student. Okay, and then you're using JPA annotation like ID, generated value, column, and things like that. In terms of programming model, you could use either session factory object or you can use a bit high level utility class called the Hibernate template. Okay, so this is actually recommended. Okay, so Hibernate template is a helper class that simplifies Hibernate data access code. Again, it handles the exception, Hibernate specific exceptions to data access exceptions. Okay, so this is a recommended class to use. So this is optional in which we are using session factory object. So here we auto-wire session factory object. So session factory object is dependency injected into our code. And then we have store method and delete method and the find by ID method, which is our implementation of this DAO interface. And then we are basically performing those operations using the session method of the session object. So here from a session factory object, we get the session object, and then we perform the methods of those session object, save or update, get or get, things like that. This is the case that we are using Hibernate template utility class. So here we are auto-wiring Hibernate template. So here you can just use Hibernate template and save or update method, delete method, and get method, and things like that. So it's a little bit simpler than the previous option 1 case in which you are creating session factory object and then create a session object. All right. So here we are playing around with the 3 different examples. The one is we are using XML mapping and then using session factory combination. So this is the programming model. We are using session factory instead of Hibernate template. And here we are using domain mapping class, domain mapping XML file. The second example is the same thing, but we are using annotation. So here we are not creating domain XML file like a student.html XML file, but we are using annotation in domain class. And third example is you are using annotation. This time you're using Hibernate template class. Okay. So result is going to be pretty much the same. So here let's try XML mapping session factory and let's run the application. Okay, so nothing really particularly interesting. So here, let's see the code. So this is the case. We are using XML mapping. So we have XML mapping file called student HBM XML file. So this is the Hibernate mapping file, right? Okay, which we have seen. And then we are going to use, if you take a look at the DAO class, so we have a student DAO, and now instead of JDBC student DAO class, we now have a Hibernate student DAO class. Okay, so here we auto-wire session factory object, right? So We are using auto-wired annotation at the method level, but you could use auto-wired right here as well. So we got the session factory object, and then from the session factory object, we got the session object, and then we perform save or update. Okay. The next example is we are using still session factory object, but we are using annotation. So in this case, we don't have the any mapping file. Instead, for student class, so if you take a look at domain class, now we have this entity annotation table and all that stuff. So if you run the application, it should result the same. Okay, the result is the same. The next one is we are in this case using annotation, and then we are using Hibernate template class. So again, if you go to DAO class, this is the Hibernate student class, DAO class, and here we are using basically Hibernate template, which is auto-wired. Okay. All right, so if you run this code, it should result the same result. Okay, all right, so hopefully that's clear. Let's move on. Okay, now the last one we want to deal with the JPA. So JPA is an API as well as a pluggable architecture. It actually provides pluggable architecture, meaning JPA engine, sometimes it's called the persistence provider, can be plugged in through configuration. So the possible JPA engines you can use are in fact Hibernate. Hibernate could be used as a JPA engine, meaning persistence provider, or OpenJPA or Eclipse Link. So your JPA code remain the same, and the choice of a particular JPA engine is specified in the configuration file. So this is an example. So here in Entity Manager Factory Bean of local container Entity Manager Factory Bean, you can specify what is the persistence provider, meaning what JPA engine you want to use through this property called the JPA vendor adapter. So in this case, I'm using Hibernate, okay, as a persistent provider. Here, if you uncomment this and comment this out, then you are using OpenJPA as JPA engine. So selection of particular JPA engine can be specified in the bin of Entity Manager Factory. Okay. Okay, so Spring JPA supports 3 ways to setting up the Entity Manager Factory that will be used by the application to obtain Entity Manager. So local Entity Manager Factory Bean, and you can use JNDI to get the Entity Manager Factory object, or local container Entity Manager Factory Bean. Okay, so typically you're going to use this local container Entity Manager Factory Bean. So this is the first case. This is this guy. Okay. This is actually used only for very simple standalone application. Okay. And this is the option you can use for Java EE environment. The last one is it provides the full JPA capability in the Spring-based application. So, it does allow fine-grained customization, also selection of JPA engines. So this is the example that we have seen. Here you can specify particular the JPA engine that you want to use for your application. All right. So here, this is a case that we are implementing your application using JPA. So here, we are auto-injecting persistent unit. Actually, we are basically getting Entity Manager Factory object through the persistent unit. And because this is a Java SE application, we have to create entity manager object ourselves, and then you basically perform query operation. All right, so but the key point is that this code does not have to be changed regardless of what persistent engine that you're going to choose. In this case, we are using Hibernate, okay, but you can pick and choose a different persistent engine by just changing this configuration file, okay. So let's see the code. So here we are using Hibernate as an engine. So here, if you take a look at the configuration file, so start from the beans.xml file. Okay, so it imports the JPA, application context JPA. So if you take a look at the JPA, this is where a particular JPA engine is selected. Here we chose Hibernate, okay, as a persistent provider. So this is actually, the trend. You're using Hibernate as a persistent engine, yet you're using JPA as a programming API. So you have a portability of your application. At the same time, you're taking advantage of proven persistent providers such as Hibernate underneath. Okay. All right, so if you run this application, again, it's not going to be that much different from what we have seen so far. Okay, so same result. So if you want to change to a different persistent provider, you basically change this file. Okay. All right, so that is the end of the presentation. So let me just